Hello everyone, welcome to learning about TRB systematically with me in the next 30 minutes. First, we need to know what TRB is. TRB is BIM-based quantity takeoff software, which helps all participants in the construction industry, owners, consultants, contractors, etc., to calculate rebar quantities rapidly and accurately in the full life cycle of construction projects. The 3D visualization of rebar, quantity extraction via various reports, and collaborative integration of quantities and rates make the rebar quantity takeoff specialized, precise, intelligent and efficient. So, how does TRB work actually? In the traditional quantity takeoff mode, we need to repeatedly review and analyze the drawings, and manually prepare reports by referring to the general note, floor plans, and reinforcement details. In TRB, the calculation rules are built in. By building a beautiful BIM model and quickly reinforcing, you can automatically extract quantities and export various reports. It can be said that the TRB calculation idea is consistent with our traditional calculation method. Let us get to know the whole workflow of TRB. TRB supports the import of multiple file formats, enables you to convert 2D floor plans to BIM models rapidly, pick the rebar information in the rebar details to models quickly, generate visible 3D rebar, extract quantities and generate reports promptly. Moreover, all the rebar calculations are based on the built-in rules and general note, which makes the rebar calculation more professional and accurate. In addition, TRB also achieves collaboration, sharing models with TAS and interoperating with TBQ. Finally, all these data can be exported to Excel or PDF. In this way, the BIM-based intelligent rebar quantity takeoff is truly realized. Next, let us open TRB and learn more about it. Double-click the TRB icon to open the software. First we enter the Start interface. There are some basic functions on the left, such as New, Open, Save, Close, and Settings, and there are new features on the right, mainly showing the highlight functions of each new version, as well as Help, which is directly linked to TRB Online Help Center, to help you learn the product faster. In the middle is the recently opened project list. For the first time, there is a new project wizard. Let us create a project, enter the project name, and select the corresponding rule. This is the main interface of TRB. There are 4 major modules. Modeling, the main module of the software. Here you can create BIM models and enter rebar info, and then complete the BIM-based quantity takeoff. Single element, provide a fast calculation method for some special or complex elements. BQ, quickly create BQ and extract quantities for BQ, to achieve the integration of quantity and rate. Report, provide various types of reports, and support generating quantities on demand and exporting them to Excel. First, let us have a look at the modeling module. Element navigation bar, display elements in groups. Switch among elements, and the entities that can be seen under the currently selected element are shown in blue. You can drag the bar to display element names. The 3 buttons above control the display of the element list, the display of the edit attribute and the switch between define and draw interfaces. Switch to a specific element. You can create an element in the element list and define the corresponding information in the edit attribute. The define interface is provided to define the element information more conveniently. You can switch between the define interface and the draw interface by double-clicking the element name. Ribbon. TRB adopts the ribbon design, showing commands based on functions and classified them into tabs and groups. Project setting, set project information. The built-in localized calculation rule corresponds to the general notes of drawings. All rebar are calculated intelligently according to this rule. TRB provides 3 modeling methods, corresponding to these 3 tabs. BIM model, support sharing models with cubicost TAS. No need for secondary modeling. One-time modeling to quickly complete the quantity takeoff for architecture, structure and rebar. Identify, support intelligent identification and modeling. You can import drawings in multiple formats, DWG, PDF, JPG, and quickly identify models and reinforcements. Draw, you can freely draw and build models as per the drawing. In addition, for the Identify and Draw tabs, according to users' operating habits, the menu is divided into general functions, do not change when switching among elements, used for all elements, and specific functions, change when switching among elements, used for specific elements, making it easier to find and use the commands. View, provide functions for viewing and displaying models comprehensively. Tool, provide small tools that make the calculation of rebar quantities more convenient. Quantity, provide various quantity check methods, rebar 3D, rebar schedule, view quantity and so on, making the rebar calculation more intuitive and the quantity extraction more flexible. Quick access toolbar, quickly call the frequently used functions. Dynamic control bar, quickly view 3D models, switch views, display styles, set floor and element display, etc. Toolbar, switch between zones, floors, elements, etc., as well as trigger some function. Status bar, show floor height, the number of selected entities, snap points, operation prompts, cross-element selection, etc. Drawing area, the main area for model display and relevant operations. That's all for the introduction to the modeling interface. Next is single element. The single element is mainly used to process the special and complex elements. It has 2 tabs, identification and parametric input. Identification, calculates the rebar by identifying and measuring 2D drawings. Parametric input, provide the rebar parametric diagrams of various elements, helping to generate quantities rapidly by selecting built-in parametric diagrams. Next is the BQ module. It supports creating or importing Excel BQ, to quickly extract BQ quantities and directly generate BQ reports. It also supports sharing data with cubicost TBQ to quickly extract quantities and generate tender documents. Finally, we come to the report module. The software provides a variety of report templates, which can be exported to Excel easily. The various quantity check methods and custom designs help to meet any needs for quantity extraction. Above is the overall introduction to TRB modules and interfaces. I believe you have got an overall understanding of TRB. Let us learn more in details from the actual case. Once we get a set of drawings, the first thing is to adjust the project settings as per the general note. In project information, set the basic information of the project, such as project name, owner, designer, etc. In floor settings, according to the actual drawings, create zones and floors, including overground floors, underground floors, or typical floors. Adjust the anti-seismic grade, concrete grade, cover thickness, anchorage and lap values, and standard length, based on the actual project. You can copy the values to other floors, or restore to the default values. In calculation rules, TRB provides various rules. Of course, the default values of all settings are in accordance with the local common standards. You just need to adjust them under some special circumstances. For example, the kicker of the column, and the densification settings of links, and so on can be adjusted according to the actual drawings. For each element, you can select the corresponding node as needed, and the green font can be modified. After all the settings are completed, you can import and export them, or restore them to the default values. In specific weight settings, the specific weight of rebar, the steel fabric information and so on, generally, do not need to be modified. In links settings, TRB provides various links forms, including closed link, open link, and torsional link. If you encounter special links, you can also customize the shapes of the links. In bend and hook, you can adjust the hook value according to the actual drawing, which will affect the rebar quantities. In lapping settings, TRB provides multiple lap forms, which can be modified as needed. In tension, compression settings, you can set how to determine the tension or compression. In wastage settings, you just need to make adjustments as needed. When the settings adjustment is completed and the zone floors are established, we can start to build models and make reinforcement. Before we start, we need to understand two sets of concepts first, element and entity. There is no solid model for elements, and entities have solid models in the drawing area. We can use one element to draw multiple entities, but one entity can only correspond to one element. Public attribute and private attribute in the software. All blue fonts are public attributes. Once you modify the blue font, no matter it is for entity or element, all elements and entities with the same name will be modified together. All black fonts are private attributes. Once you modify the black font, if it is for the selected entity, only affect the currently selected entity, not the corresponding element. If it is for the selected element, only affect the corresponding element, not the entities that have been drawn before. Next, let us start modeling. If you get an identifiable CAD or PDF drawing, you can quickly identify it and build models. It requires only 3 steps: pick sideline, pick label, auto-identify. These 3 steps are applicable to all elements to convert 2D drawings 3D models quickly. Let us see how it works. Switch to the Identify tab, click Drawing Manager, and add a floor plan. Identify the axis grid first. We use 3 steps: identify axis label and auto-identify axis grid. To identify the axis grid successfully, go to column and identify the columns. We also use 3 steps: pick sideline, pick label, and identify, to identify the columns successfully. Let us look at them in 3D view. The next step is to identify beams. We still use 3 steps: pick sideline, pick label, and identify, to identify beams successfully. Let us check out the 3D view. Isn't it very fast? Then we will identify walls. The wall plan is on another drawing, so we import the drawing, locate it, identify wall, and switch to the 3D view. That is all for identifying walls. Follow the same identification steps to deal with the remaining elements. We can also copy the model of the current floor to other floors to complete the modeling of the whole building. If what you get is not identifiable PDF JPG drawings, you can manually create models. What you need to do is also very simple: import the drawings, and then follow the 3 basic steps of manual modeling to build models. New element, define, enter drawing information, draw model entities. All element models can be created through these 3 steps. First, import the drawing and scale it. To draw columns, we use 3 steps. Create a new column, define its name and size in the Edit attribute, point draw the column as per the drawing. You can use F4 to switch the insertion point for drawing, or use the rotation point function to draw columns. Perform the same operations until all the columns are successfully modeled. Next is the beam. We can also use 3 steps. First, create a new beam. Define the beam name and size in the Edit attribute, and draw beam by tracing the lines on drawing. Define and draw beams consecutively until all beams are modeled. Next is the slab. The same method is adopted. New, define, and draw slab by using point or line. Do this consecutively until all slabs are modeled. Of course, we can also directly import the TAS model since the model sharing between TAS and TRB is achieved. Either way, after completing the model, we start to arrange rebar. First comes the column reinforcement. If you have a column detail drawing, TRB can automatically identify it, like this. Column detail, import the drawing, pick sideline, pick label, pick rebar line. You can choose click identify or auto identify. All the rebar on column details are automatically identified. Of course, for all columns, you can enter the rebar information in the Edit attribute as per the reinforcement drawing. In addition, you can view the supported input formats by clicking the More button to easily handle various businesses. If the column reinforcement is relatively complicated, such as these diagrams, we can draw the rebar directly in the Edit section window of column. After calculation, when performing rebar 3D or Edit rebar, you will find that the rebar quantities are generated according to the custom arrangement. In addition, TRB provides column schedule that supports quick identifying and manually entering, helping to manage the column reinforcement systematically. Select the appropriate column reinforcement method as needed, complete the column reinforcement, and then after calculation, you can get the quantities of all column rebar. Next comes wall reinforcement. This is a wall reinforcement drawing. Create a new wall, enter the rebar information in the Edit attribute as per the drawing, draw, calculate, and click 3D rebar and Edit rebar. If there is an opening in the wall, the rebar in the corresponding location can be deducted automatically, and the rebar information can be synchronized to other walls. We can view the rebar arrangement, trimming bar and so on. Next is beam reinforcement. Side label. For beams, in addition to entering the rebar information in the Edit attribute like columns, because the beams have different beam spans, and the rebar in different beam spans may be different, we generally use side label for reinforcement. Select a beam, click side label, and you can see that the beam is split into several beam span based on the auto-judged beam support. You can enter different rebar information in sequence for different beam spans. After calculation, you can view the beam rebar by using rebar 3D and Edit rebar. Of course, if the drawing you get contains this sort of beam schedule, you can use TRB to identify rebar quickly. Import the drawing, click Identify Schedule, drag select the beam schedule, and right-click. In the first row, match the information of each column, click Generate in Beam Schedule, and then all the information will be automatically generated into the beam schedule of TRB, and the identified rebar information will be synchronized to the beam entities. Click Sum Calculate, and the beam rebar will be automatically calculated. If the drawings you get are identifiable beam details, you can use TRB to identify rebar quickly, like this. Select a beam, click Rebar Layout, import the drawing, find the beam with the corresponding name according to the drawing, and identify the main bar. Refer to the operation messages below. click the rebar information, click the rebar line, right-click to confirm, and the rebar line is successfully identified. Identify all rebar lines consecutively. After identifying main bars, identify links. Click rebar information, click section information, and draw the area to arrange links. Right-click, and then the links will be identified successfully. Identify other links consecutively. In this way, the rebar of this beam are all identified. We can continue to identify rebar of other beams. Follow the same operation steps until we have identified all of the beam rebar. After exiting the rebar layout, you can view the identification result for rebar. For Indonesia, if the beam drawing you get is a beam section drawing, you can use TRB to identify rebar intelligently. First, let us look at the beam section drawing. Pick information, auto-identify, and the rebar can be automatically identified to the beam schedule. In addition, you can locate them for inspection. The same is true for the side label drawing of beam. Pick information and identify it, and then you can quickly identify the rebar, which is very fast and convenient. I will not go into details here. Next is slab reinforcement, which is slightly different from other elements. The reinforcement is not controlled by the attributes. You need to define the slab bar elements separately. Let us see how it works. This is a common slab bar drawing. Generally, we model slab bars according to the drawing. New slab main bar, define attributes, enter rebar information, and edit slab bar type, then draw. We can arrange slab bars horizontally or vertically to single slab. Arrange them horizontally or vertically to multiple slabs. Arrange them to a custom range, etc. Of course, we can also use arrange slab bars by tracing lines on drawing. TRB provides a variety of reinforcement methods. After all slab bars are arranged, calculate and view the rebar 3D. When encountering the slabs with height differences, the slab bars can be automatically calculated based on the variable section. If you encounter such identifiable slab details, import the drawing for identification, pick rebar line. Pick label. Pick range line. And click Auto Identify, and you can see that the slab bars are quickly identified. After identification, you can double-click to locate the slab bars and view the identification result. In addition, you can check the identification result by area. If you encounter some unidentified ones, you can draw lines to arrange slab bars directly. In this way, the slab bars are calculated quickly. For Indonesia and Taiwan, if the drawing of slab reinforcement is like this, you can use parametric reinforcement in TRB to deal with them rapidly. The following is about foundation. Here we take pile cap as an example. Create a pile cap, enter dimensions and rebar info in the edit attribute, draw, calculate and view the 3D effect and calculation results. In addition, you can also create parametric pile caps, or custom pile caps. It also supports synchronizing information to other pile caps. For raft foundations, the reinforcement is similar with that of slab, so we will not illustrate that in details here. Please note that you can set slope edge for raft foundations, and the raft rebar can be automatically calculated according to the slope edge. Until now, we have completed the introduction to the modeling and reinforcement of the primary elements of buildings. Next, let us have a look at some complex miscellaneous elements. Under each element, TRB provides the attributes of other rebars and other links, where you can quickly customize any reinforcement. For these complex elements, TRB also provides another way to take off quantities rapidly, that is, the single element module. In this module, there are two modeling methods, identification and parametric input. Here we use staircase as an example. First, create a stair element, and then under the Identify tab, import drawings to quickly identify rebar. Under the Parametric Input tab, you can select an appropriate parametric diagram, modify the information according to the drawing, and then quickly generate rebar. It also supports inserting rebar information manually, which is very convenient and flexible. When all rebar quantities are calculated, we proceed with the BQ to quickly complete the integration between quantity and price. Let us switch to the BQ module. BQ TRB supports manually creating BQ and importing Excel BQ. We can extract the quantities from BIM models and fill them in the BQ rapidly and flexibly, and then sum them up in BQ reports. In addition to this method, if you are using TRB and TBQ, at the same time, TRB supports linking TBQ. According to the BQ items in TBQ, in the View Quantity by Category window, you can drag the rebar quantities into the BQ items. Moreover, the source of all quantities could be checked reversely. Upload the quantities to TBQ, and then the integration between quantity and price is truly achieved. Of course, if changes occur, for example, the model size changes, you only need to recalculate the quantities, and the BQ can refresh the latest quantities. At the same time, the variation quantities can be quickly generated, which is very intelligent and efficient. Finally, let us look at the report. TRB helps to auto-generate a variety of reports, such as rebar schedule, rebar summary and so on. You can export reports as needed. Of course, if the built-in reports fail to meet your needs, you can use TRB to customize your own report. Select the classification conditions as needed, and customize the report format, which is very flexible and convenient. That is all for the actual cases. All the way from project settings, modeling, reinforcement, BQ, to report, following the traditional quantity takeoff idea, TRB has completed a gorgeous transformation from 2D quantity takeoff to 3D quantity takeoff. Because TRB, BIM-based rebar quantity takeoff. Stay tuned for more.